Hi friends, this video is going to talk about how to make the adjustments from graphing tangent to graphing cotangent. Okay, so really there's just a couple of adjustments that need to be made, but let's talk first about what does the actual graph of cotangent look like and why. Okay, so first we talked about how to graph the function y is equal to tan x by first finding the period, and we remember that the period is pi over b, and then taking the period times 1/2 to find our first asymptote, and then we can add the period length to the first asymptote to find a second asymptote. So in this case, okay, so if I'm looking at this function, we know that the period is going to be pi over 1 because the b value here is 1. All right, and if I take that pi and multiply it by 1/2, we're going to get pi over 2, and that's going to be our first asymptote. Okay, so let's just do that much. 1, and then I can add pi plus or minus pi to find the rest of my asymptotes. And if you look at this graph, you can see that pi units is equal to 4 of those tick marks in this case. So I can make asymptotes every 4 tick marks. So 1, 2, 3, 4, 1, 2, 3, 4, and then backwards 1, 2, 3, 4, okay, and 4. Okay, all of these are asymptotes for this function y equals tan of x. And then remember that we took and plotted a point right smack dab in the middle of those asymptotes for our x-intercept. And then from there, we looked at the vertical stretch here, the a value, to find the y value of the point to the right of the x-intercept and to the left of that asymptote. So this would be here, 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 oops. And then on the other side, we would go down to -1. Okay. Lovely. Okay, and so we would go do something like this, right, for each of these. All right. Okay, now, if we remember, okay, so all of this is kind of a review of how do you graph the function y equals tan of x. Now, if we remember that cotangent of a function of a value is equal to 1 over the tangent of a value, what that means is everywhere that I see a 0 value, okay, so if I see that tan of x is 0 here, 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 or my x-intercepts, if I put that in the denominator or shift that down here, I'm going to get something undefined. And so that is kind of where our asymptotes move to for the cotangent function. So anywhere there were x-intercepts, there are now asymptotes, okay? So I'm going to replace all those x-intercepts with asymptotes. So I'm going to clean this up a little bit. I'm going to get rid of the old asymptotes. All right, and here we go. Okay, so let's get rid of that x-intercept too, because now this is what we have as far as asymptotes go. So notice, before with y equals the tangent of x, our asymptotes were on the left and the right of the y-axis. Now it's smack dab on the y-axis, right? And the length between them is still the same, right? Pi units. Okay, so that's one of the big differences. Now, if we think about where the cotangent is, let's see, let's put our x-intercepts in the middle like we did before. And then here, our cotangent is going to be, instead of going up from left to right, we're going to go down from left to right. Okay, because they're actually the same values here as what were before, except now the asymptotes are in different places, and so these actually fall from left to right. Okay, and so we have something that looks like this. Okay, right. Okay, so what we have here now in green is the graph of y equals the cotangent of x. So a couple of things to remember. If I'm talking about y equals the cotangent of x, what we have is asymptotes on the y-axis and pi units to the right and to the left, and we have a function that decreases. If I'm talking about y equals the tangent of x, then what we have is here's my axis. We have got asymptotes to the left and the right of the y-axis, and we have a function that increases. Okay, so something like that. All right. Other than that, everything else is the same. Okay, so now let's get into actually graphing the function that we're given here. All right, so a couple of things. Let's go ahead and start with, let's clean this up a little bit first. Let's start with the function that has not been translated. All right. Let's start with y is equal to the 3/2, the cotangent of x, okay? So it would look like, let's see, let's start here. Y is equal to 3/2, the cotangent of x, all right? So we know that the period is going to be pi over b, which is equal to pi over 1, which is equal to pi. We also know with cotangent, our first asymptote is on the y-axis, and then we would add the period. Okay, let's get that far. Okay, so let's go ahead and plot this here. And I'm going to go pi units over. Okay, now I'm going to take and plot my x-intercept, and then I'm going to plot my 2 points, one to the left and one to the right. And remember that this graph decreases. Our y value was going to be 3/2, so we're going to be at something like looks like this. Okay, now remember that this is the graph of y equals 3/2 cotangent of x. Now we need to now apply this translation, which means I'm shifting everything to the right 3 pi over 4 units. So everything is shifting to the right 3 pi over 4 units. Now if the distance between these two asymptotes is pi units and it's divided into 4 sections, I'm shifting everything over 3 of those tick marks. So my new right-hand asymptote is just going to be here. And my new left-hand asymptote is going to be here. My new x-intercept will be here. And then I'll have my 2 values at 3/2 and -3/2. And that would give us the graph that we're looking for. So start by graphing, or at least getting it in your mind where this graph would be, and then shift everything by using the horizontal translation there. It would be a phase shift if we were talking sine and cosine, but it's tangent, so it's just a horizontal translation. I hope this helps, and I'll do another one that is the other type of problem here in just a second.